Whenever we find a solution to a problem using an algorithm, there is a possibility that if there are five people, the logic of or the approach to solve the problem of all the five people could be really different. Now, how do we make a choice which algorithm or whose logic to use? So, for that, you'll be studying completely something called as analysis of algorithms once you join engineering, BCA, MCA, MBA, or all these courses about how to choose algorithms based on different parameters of performance. So, what the moral of the story here is, whenever you are solving a problem, I may have a different logic, you may have a different logic, but as long as we are getting a correct answer, both are fine. But at times we are required to make a call which logic or whose logic to be used for solving a given problem, because we generally prefer a solution which takes less amount of time to calculate or compute and also uses resources optimally, in the sense uses less memory, less storage space, and so on. So we choose a particular approach analyzing two items. We analyze the time taken to execute a particular algorithm and the space required to do the calculations. So in real life, it is very difficult to get a perfect algorithm which consumes least amount of time and takes least space. So you got to really do a balance of time and space requirements. One algorithm may take more time but consume less space. Other may consume less space but take more time. So you have to make the right choice depending upon what is important. On certain systems, time may be very important, memory may not be such an important criteria. On some other machines, it may be okay to take a little more time, but it should utilize minimum memory. So you got to make the right choice about which algorithm you got to use. So, what is space complexity? The amount of space required by the code and data, or for processing data by that particular algorithm, is referred to as space complexity or space analysis. So the code occupies space, the data occupies space, and for intermediate calculations, it requires a certain space to store data, retrieve data. So that is the space complexity. Now, what is time complexity? Very simple. The time required by the algorithm to complete processing whatever problem you are required to solve and give a solution. Ideally, you want fastest, but in real life, there has to be a real balance between time and space. But most of times, the performance of algorithm depends upon the input data. You give it data which is not friendly to find, it will take more time. Certain data it will find faster. Let me explain what I mean. Suppose I have numbers in boxes stored between 1 to 100. If I am searching for the 99th number, okay, and let's say the numbers are randomly distributed in the boxes, or let's keep it simple, okay, let's take it like this. Let's say I have box 1, this is box 2, this is box 3, this is box 4, this is box 5, and all the way up till box 100. Okay, so whenever I am required to find a number, okay, let's say box 1 contains 1, box 2 contains 2, box 3 contains 3, box 4 contains 4, box 5 contains 5, box 6 contains 6, box 100 contains 100. So if I have to search for 56, I have to keep checking the values in each box, and I can go and find in the 56th box that my number 56 exists. But suppose I say search for box number 1, the search is the fastest. Search for box 100, the data is the search is the slowest. So based on what data I am searching or what type of data I am working with it, that leads to faster performance or slower performance of your logic. So based on the data, you have three types of performance. The best case, suppose I am searching for one, I'm lucky, that is the fastest because it's at the beginning. Worst case, suppose I'm searching for number 100, that is the worst case because that is at the very end. Average case, which takes the average between best and worst case. Number 50 could represent your average case because it takes half the time between best and worst case. So most of the time your performance will be between the average case. Best and worst case will happen once in a while, but you got to always design so that it works for the worst case, because worst case unfortunately can occur in real life and create problem for your system. Like for example, I'll give you what about worst case. Suppose your results of PUC, CET or NEET are declared, in the full year, maybe about 50 people in the day may be checking the result. But when the result is declared in that 1 hour, maybe 5 lakh people are trying to see the result at the same time. So that is the worst case. It should work in that worst case correctly without causing any problem. Now there's a last keyword called as pseudo code, which comes in your textbook. Pseudo code is also approach for writing the logic or description of the program logic similar to an algorithm, except like it is more English like. Okay, it uses constructs like if else if, while, repeat, end, do, all these things. It uses loops, it uses decision making and so on, but it is almost English like writing. What a pseudocode is, pseudocode is used to explain the logic of a program to a human being as opposed to that of a computer by a programming language. So pseudocode is used for people like who really need to know how things work. They are not interested in the details of how it works on a programming language. So I hope that clarifies what is a pseudo code.